Hello, we are Group 4A, and this is our drainage case study.
Here's the scenario that we are given. You are the new superintendent of the Thousand Oaks Golf Club in Revelstoke, BC. Inspecting the course for the first time, you notice the rear edge of your fifth green is crusted with algae and waterlogged. Your greens are push-ups with low hydraulic conductivity but are otherwise performing very well. You must assess the problem and determine what kind of drainage to install for the problem. You determine your root zone is about 8 inches of topsoil. You want to remove water from the surface at a 0.5 inches per hour rate for minimum for acceptable play after rainfall, which might be expected during the area's most severe rainstorms. We must perform the Hugout calculation, discuss at least 3 options to improve the green, estimate the cost of our decided project, and our solution for the drainage problem. In this scenario, gravel costs $20 per yard cubed, sand is $38 per yard cubed, 4-inch tile is 41 cents per linear foot, and slit drainage tile installed is about $1 per linear foot. Each catch basin costs about $30 each, and multi-flow tile is about 80 cents per linear foot.
Upon further inspection, we've identified that the cause of the algae growth and waterlog is due to poor drainage. The poor drainage could be caused by a number of different reasons, including a clog from the buildup of silt within the Big O piping, the slopes shifting and changing over time, and or collar dams creating a bowl for water to collect in. In the theory section, we've included 4 options for dealing with the problem. Option 1. Because we are dealing with only a small area of one of our greens, the most realistic option in terms of time investment and cost effectiveness is to just simply resod the area and wait to see if the problem persists.
Our third option is to install a sub-air system. The sub-air attaches to our drainage system. Even though the vast majority of the water will gravity drain to the front of the green, the air and a small amount of water are pulled to the back of that green, and once pulled back here, the sub-air system has an air-water separator. This then separates the water from the air and can be used in either vacuum mode or pressure mode. In a scenario where money is not a problem, sub-air is always the best option. On subairsystems.com you can see a demo of how the program works. On vacuum mode, it sucks air up and this forces the water down through the drains. Our third option is to reinstall the entire drainage system underneath number 5 green and rebuild it to USGA spec. As seen by this citation, if you build greens properly using our method, they don't see a need for sub-air.
Option 4 is to locate and replace the problem lateral drain line. This will require troubleshooting and reference to the course drainage map in order to locate the line. Besides resodding just this problem area, this will be the second most cost-effective option.
So to begin our evaluation, first we have to calculate the area and volume. Our troubled area requires 50 square feet of sod. Our trench area requires another 30 square feet of sod for a total of 80 square feet of sod. Our total trench volume is 20 feet long, 20 inches deep, 18 inches across for a total of 50 cubic feet. We need 20 feet of 4-inch Big O, which is equal to 1.744 cubic feet. We need 20 cubic feet of gravel. We need 28.25 cubic feet of backfill root zone mix, which we already have. And we need 27 cubic feet of top dressing sand, which is also equal to 1 cubic yard. So after weighing all 4 of our options, we decided to go with option number 4, which is to replace the damaged lateral line. This is the most cost-effective long-term option while allowing us to keep the hole open for regular play. This is an in-house project and will allow us to observe and replace the existing drainage in that specific affected area. The affected area is very small, only 50 square feet, so we do not need to do a total overhaul of the drainage in the entire green. Because this problem occurred in the middle of the season, we can rule out that any winter damage or spring melting caused this problem. Although this area of the green will have to be marked as ground under repair, the area is less than 1% of the surface area of the entire green and is along the back right edge. After the repair, we will continue to do evaluations of the area to ensure the drainage issue has been fully rectified.
For our cost, we priced out our Big O tile, and it will cost $8.20 for 20 feet of it. 1 cubic yard of sand will cost us $38. 2 cubic yards of gravel at $20 a cubic yard, $40. We have our 80 square feet of sod from our own nursery. We also have our own backfill material and labor. This will take 2 employees, 2 8-hour shifts at $15 an hour, which is $480. Now, if we look at the total cost for this project, it is $566.20.
Hoog's formula is used by engineers and other industry professionals to calculate the drainage rate between subsoil drains. The formula is as follows. D is equal to the drainage rate, K is equal to hydraulic conductivity, H equals the height of your root zone, and S equals the distance between drains. To put it simply, Hoog's formula describes that the further apart drains are, the slower the area will drain, and that the shorter the root zone is, the slower the area will drain.
To conclude, we believe that we selected the best option based on the parameters that we were given. If this problem had occurred during the shoulder seasons, we may have reevaluated and taken a different approach. Because this problem was determined to be mid-season and was relatively small, affecting less than 1% of only one green on our entire course, we are happy with the option we chose and are confident moving forward that this will not be a reoccurring problem and that this is a great long-term solution.